talked about electrons. Remember the electrons are spinning like around, like they're going around the nucleus real fast, like this. And they stay on these pathways, the energy levels. And there's a maximum capacity. Just like Highway 280, there's a maximum number of cars that can get on that highway. All right, if you go past that, they're gonna be backed up on the ramp, but they won't be on the highway. So it has a limited number of cars that can get on the highway. Just like these energy levels around the nucleus. It can't hold an unlimited or an infinite number of electrons. There's limits. And remember, in the atom, we fill them up. We fill up these energy levels from the inside out. So you got a whole herd of people in the middle waiting to get on a roller coaster ride. First row fills up, second row, third row, fourth, all right? So we're gonna start the first row. It's gonna be the inner orbital. That's orbital 1, can hold a maximum of 2 electrons. Second row is energy level 2. It can hold 8 electrons. Third row is the third energy level. That can hold 18. Fourth energy level, so that's like the fourth row in the roller coaster, can hold 32. So think of roller coaster rows. They all start from the inside though. Fill them up from the inside out. Now, that last energy level is where all the action is. So if you think about, that's the last row in the roller coaster. That's where that last row on the roller coaster, and they're sitting in the back. You get to see all the action. You look up, everybody's woo, ah, ah. You know, they're doing selfies up, like you see all this. And, I mean, you see, when you're in the back, when you're in the last row, you see everything in front of you. That's where you can see everything. So think of it that way. And the electrons on the outside most energy level are called valence electrons. Valence electrons. This is where the action is. And if atoms and nature really want stability. It's just a natural process in which things kind of gravitate toward stability. You don't like instability, like you do. So stable, like a roller coaster. You'd like to have the rows all filled up, just like, because it makes you feel more secure. If you're the only one in that row, you're like, wondering if you're gonna be able to hang on. You wonder if the seatbelt's working. That's always a challenge. Like, God, I was like, every time they lock you in, I'm like, is this thing gonna hold me in? And then you're looking at the person next to you, like checking out the seatbelts, and theirs isn't working either. So you're like, all right, well, if we both go out, at least I got somebody that's gonna fall out with me or something. But if you're the only one in the row, then you're wondering, why is there nobody else here? What's wrong with this roller coaster? They get nervous. Just like with atoms, there's a natural gravitational, there's a natural things want to be stable. So if atoms have all of their energy levels filled up, they're stable. They're like, oh man, this is like, they're comfortable with it. It's like a roller coaster ride. If all the rows are filled up, it's like you feel comfortable. Like you're not nervous, you're not reactive. However, if they're not filled up, there's reactions. The people get excited, they get nervous. And atoms that don't have their energy levels all filled up, they are more reactive. So they can react very fast. All right, stable atoms like iron, they're not going to react as fast.